Welcome to another episode of the .NET Show. In this episode, we're going to talk about connected systems. Now, connected systems means allowing you to take your business logic, place them on the network as web services, and give your users the power of the aggregation of all those services together to provide a much richer experience for them. But before we get to that, let's check in with Erica and the news.
Hello, I'm Erica Wiechers. Welcome to the MSDN News Update. On August 6th, Microsoft announced the release to manufacturing of Windows XP Service Pack 2 with advanced security technologies. This free service pack delivers the latest security updates and innovations from Microsoft, establishes strong default security settings, and adds new proactive protection features that will help better safeguard computers from hackers, viruses, and other security risks. In related news, on August 25th, Microsoft announced availability of the Windows XP Tablet PC Edition 2005 operating system, the successor to Windows XP Tablet PC Edition introduced in November 2002. Included as part of Windows XP SP2, this free upgrade offers tablet PC users deeper pen and ink support, including a redesigned input panel to create and enter text anywhere within Windows XP and familiar Windows XP compatible applications. Currently, more than 300 independent software vendors are creating innovative software solutions that take advantage of pen and ink capabilities in the tablet PC operating system. On August 10th, BAE Systems, IBM, Microsoft, SAP AG, and Sun Microsystems announced the submission of the latest version of a key web services specification, WS Addressing, to the World Wide Web Consortium as input into the standardization process. WS Addressing helps enable organizations to build reliable and interoperable web services applications by defining a standard mechanism for identifying and exchanging web services messages between multiple endpoints. On August 27th, Microsoft announced it will target broad availability of the Windows Client Operating System, codenamed Longhorn, in 2006, and make key elements of the Windows WinFX developer platform in Longhorn available on earlier versions. Specifically, the new presentation subsystem, codenamed Avalon, and the new communication subsystem, codenamed Indigo, will be made available for Microsoft Windows XP and Windows Server 2003 in 2006. In addition, Microsoft will deliver a Windows storage subsystem, codenamed WinFS, after the Longhorn release. And this has been the MSDN News Update. I'm Erica Wiechers.
Welcome back. Like I said, in today's episode, we're going to talk about connected systems. To join with me on this show to talk about that, we have Doug Purdy and Don Box. Thanks for joining us.
Thanks for having us.
Thank you.
Now, connected systems, is this like a new product coming out of Microsoft, or what exactly is it?
So it's not a new product. It's an observation that, a given organization or a given, ISV vendor tends to write programs that don't go away. And a large aspect of what people do with the technologies that we've been providing over the past 10 plus years is try to get the programs that they've already written to work with new programs that they're writing. And so connected systems is really just an acknowledgement that there's really one large body of software that people manage and that people own. And getting the integration points between those pieces of software, the subsystems, getting that integration to be natural, fluid, efficient, is really kind of the focus of what we do with connected systems at Microsoft.
Some existing program, you're talking about legacy applications, or?
Every program's legacy eventually, right?
Yeah.
Ultimately, a given organization has tons of software assets, and making those assets work together, that's the point. And so if you want to think of that as, I've got legacy programs, which I wrote yesterday, and tomorrow's legacy programs, which I'll write, tomorrow. Yeah, making those work together is really, kind of the focus of the work we're doing in this space.
Isn't there something that just makes sense to make these programs work together? I mean, why do we have some initiative that's labeled connected systems to talk about?
Yeah, well, I don't know that I would actually say we have an initiative. I mean, we certainly have a theme for thinking about a group of technologies. So Doug and I work on the Indigo team, and we own a bunch of connecting technologies. So we're responsible for MSMQ, which is obviously used to connect systems together. We're responsible for COM and DCOM, which again is another technology used to connect systems. And of course, we own the XML messaging stack and all the web services plumbing, so ASMX. And of course, the Indigo, which is an actual technology that we're building, which I think is kind of the culmination of a bunch of technologies that have been used by our customers to glue the software together. And so, this whole arc of technology that we work on is about connecting one program to another. I mean, that's all we do. And yes, it's, it's not real sexy, but it turns out to be pretty important.
And how do programmers and businesses actually try to take advantage of some of these features and capabilities?
Oh, well, I think as Don said, our team is responsible. So at Microsoft, we have one team, the Indigo team, as is largely known. We work on both the Indigo product as well as the technologies that Don highlighted, as well as MX, which is a managed technology for writing web services, .NET Remoting, another managed technology, COM Plus, MSMQ. And so from a connected systems perspective, when you look at a problem of trying to integrate all these various pieces that you may have, or adding a new service or adding a new application, then we have a suite of technologies that you can utilize to plug into your existing architecture or with your existing applications. And we have a stable of things, some of which do some things better than others. We have fairly clear guidelines on when you should use a particular piece of technology and when you should use a different piece of technology, and you apply that to your enterprise or you apply that to your application. One of the unfortunate things about having, well, I guess it's a twofold thing. One is that, hey, we have a lot of different solutions that you can apply based upon your particular scenario or your particular problem. But at the same time, it would be nice if there was only one technology that Microsoft provided that would apply in all of those different scenarios. And that's the problem largely that Don and I are trying to solve, and our team, the Indigo team, is trying to solve, where we look at all the scenarios and all the technology stacks that we have currently, and we say, we'd like to have one of those things so we can eliminate choice from a developer but provide the same set of scenarios and the same set of skills and the same set of technologies. And we call that thing Indigo. And so Indigo moving forward is the way that people will build connected systems. But for the time being, we have a slew of technology. Well, I won't say a slew. We have a number of technologies. And, well, I guess it would be a slew.
It's a plethora.
It's a plethora of technologies. And we're trying to get out to the community fairly clear guidance on when to use each of those pieces.
Now, for a programmer that's got existing applications, how do they approach making them connected and adding support for Indigo or MSMQ or something like that? Is that something they have to think about from the very beginning when they started writing the application, or can they add it after the fact?
Quite often it gets added after the fact. Designing for these ideas up front is a luxury a lot of organizations don't often have. And I think a lot of the technologies that we shepherd are fairly good at allowing you to take an existing piece of code that you've written with, often a fairly simple set of assumptions, and put, a messaging facade in front of it so that, this software asset that I had that maybe I intended to be accessed, only over a, HTML-based browser UI. I can take that same software asset and put, say, an ASMX facade, which gives me XML messaging access. Once I do that, yeah, I still got, I don't lose my original user interface that happened to be HTML-based. What I've done is I've gained yet another entry point into that same code and equally importantly, that same information, because more often than not, these systems are not just behavior. They're not just code that some developer is responsible for keeping running. Quite often, they're actually maintaining, or they are the entry point into critical information, critical data that people need to run their businesses or to keep their home going. Like I've ripped pretty much every CD I own, and that information is super critical to me. And the fact that I've got a service that sits on top of it and makes that music visible to other parts of my home network, that's a great thing. But the data also is at least as important.
And the data itself doesn't really understand the fact that it's part of a larger whole. It's just data unto itself.
Yeah, and really kind of the metaphor that we've settled on after looking at all these technologies and living with this stuff is the code that makes the data visible, makes the data accessible. We call a service, right? And a service is really a program that responds to messages, right? It's a very simple definition, and that program invariably has data associated with it. And it's conceivable that you'd have services that have no data. Certainly, a time of day service, which is obviously a basic utility, but it's not super interesting. Doesn't really have interesting data, but more often than not, you've actually got data stored in the file system. You've got data stored in databases, data stored off in directories, what have you. And so services quite often are used to put, a behavioral, structured, controlled facade on top of whatever data you happen to have laying around.
So if you've got an existing set of business logic components and stuff like that in your application solution, thinking of them as services is what allows them to flow better into a connected systems model?
Yeah, certainly making sure that they play well in the service-based ecosystem definitely makes it easier to leverage those things in new ways.
I think the key thing here is reach. I have an existing technology or I have an existing application that is available, and it may only have one access point. Let's say that it's only available via, as you said previously, an HTML endpoint, or maybe it's only available via some sort of rich UI client. And what I'd really like to be able to do is to extend the reach of that particular behavior, or to extend the reach of where that data can be accessed from. And so services are a wonderful mechanism, connected systems are a wonderful mechanism for you to take existing applications and components and say, I really want to broaden the base of folks that can get access to this, and also allow other systems to leverage that data and other systems to leverage the behavior. Because oftentimes what we find is that many enterprises will build systems in which they have very similar sorts of data or similar sorts of behavior. And if they could simply put a facade, as Don was saying, on top of their existing components and existing data, then potentially they won't have to rewrite their applications or rewrite this behavior or store the data in another, say, repository. And this comes up a lot when you have mergers and acquisitions, of where HR systems need to go together, purchasing systems need to go together. And so what you can do is you can put service facades in front of those things and try to reuse and broaden the reach. And I think that's what we're really trying to achieve, is write your code, write your data model, and then universally allow it to be accessible utilizing service technology.
I know I've talked to a number of telecommunications companies, and one of the things that always comes up is the fact that they have their wireless division and their wireline division, and quite often the two are two separate companies almost, and there is no sharing of data resources between them. And by adding a services infrastructure to it, it allows suddenly them to have a voicemail system that you can take and access voicemail, either wireless or the wireline system. And as far as the customer is concerned, it's just one entry point, but there's two services that are providing the back end pieces to it.
Yeah, facades are a wonderful technology or a wonderful technique to hide complexity behind it. It can really, really simplify the way that people access data and access behaviors.
Now, the time used to be that when people wrote application solutions, they weren't really thinking about exposing services that could be used by other applications. They're saying, I'm writing the soup to nuts application. It's going to include a CRM. It's going to include a calendaring system. It's going to include all this sort of system. And here it is, and they deploy it within the organization or the department or whatever. Are you thinking that now people that are doing those sort of applications need to be thinking more about, I'm no longer doing the soup to nuts. I now need to take and understand what this means from a services model?
Yeah, I think the view of a monolithic application still has a place. I mean, people will continue to write programs that way, but I think there's an increasing awareness that no program is really an island. That ultimately, I write a piece of code, I'm going to want to use aspects of that code again. And back in the 1980s, when object orientation was kind of really in its blossoming, there was such an emphasis on reuse, and the reuse almost always entailed actually somehow combining the code that I'm reusing with the code that I'm using in a fairly, tightly coupled way. And certainly what we're doing with services is trying to reduce the bar of entry for reuse, such that I don't really need to understand all of your software. I don't really need to agree on a common programming language, a common platform, a common operating system, common runtime, right? And really, if I can do this protocol-based integration, which is really the central theme of the work we do, then as long as I can agree on what happens on the wire, then we're okay, right? And really the only objective reality in these systems is the messages that flow across the wire. The fact that, I've got my own local subjective interpretation of that, and I'm going to, layer a C# object hierarchy on top of it, and you're going to write, an X query implementation over on the other side. We want to have a world in which that's a fact of life. That's a natural thing. And certainly, a lot of the stuff we've been doing with web services and with XML have been to foster that kind of an ecosystem where, we have XML as an objective reality that we all agree on, and then subjective interpretation, viva la différence. Everyone can do what they want.
Mm-hmm. So, and with the technologies that Microsoft is bringing to the table for developers to use, what are the technologies that our audience should be thinking about, how they can help them developing service applications with web services or through processes and stuff like that?
So I think the number one technology, Don has a sort of shortcut. We have what I'll call a flow chart to help people sort of work through which technology they would use for connected systems. But Don has a saying, and it's, when in doubt, use ASMX, which is ASP.NET Web Services. So oftentimes, if you are interested in building a service, or you're interested in connecting applications together, or building the canonical connected system, we recommend that you utilize ASMX, utilize ASP.NET Web Services to write services. Many times that involves writing a service facade on top of existing components that are existing applications. We have other technologies that we recommend that folks use inside of their service boundary, as it were, with things like .NET Remoting, Enterprise Services, MSMQ, COM+, that people can take advantage of as well. But the key thing for us is, as Don was saying, is that the leverage point is about protocol integration, and that means XML. And now that means HTTP. Further on, it'll need other protocols. But it's largely about messages, largely about services, talking XML. And ASMX is our premier technology to make those things happen.
Mm-hmm. Mm-hmm. And so what I'm hearing out of that also is that you're talking about using a messaging-based interface, and so not be thinking about a procedural interface.
That's a very interesting sort of, what's funny is Don is talking about objective and subjective reality. How you actually process that message may be in a procedural sort of way. That is your local interpretation. You can locally interpret a message as being a method call and being parameters. And that all has to do with your local implementation. On the wire, the objective thing is an XML message that flows between endpoints. The other endpoint may choose to expose that message as a full-scale XML info set and process it accordingly. But the key thing is that over the wire, it is that XML, but the moment it hits your service, then you can interpret and process it in the way that you'd like to do that. And in Indigo, one of the wonderful things about Indigo is that we let you have both. You can view the world purely in a procedural sort of RPC-ish sort of parameter way. And then we say, that's wonderful, that's great, we're glad that you like to program that way. And we translate that into a beautiful XML info set message. But at the same time, we recognize that many programmers want to do that message-based programming inside of their implementation, and we fully allow them access to the message. So the way and the mechanism that you program the protocol and program the XML is up to you. However, the key thing is that we all agree that on the wire, how the services talk is via XML and is via over these standard protocols.
And if you look at the standard description format that all of these technologies use, which is WSDL, fundamentally WSDL is message-based, right? I declare my messages, and yes, request reply is a first-class concept in WSDL, just as it is in most messaging systems. I mean, MSMQ has a fairly strong notion of message correlation. But definitely the fact that the metadata, the type system, the contract system, which is WSDL, is message-based, is the important thing, right? ASMX, we'll do Indigo, maybe someday we'll do, something after Indigo, cyan or some other color. But at the end of the day, those WSDL definitions will last, right? The ASMX generated WSDL is going to be consumed by Indigo, and Indigo will spit out WSDL, which will be consumed by cyan or whatever the next.
And ASMX.
And ASMX. And really the substrate, right? The way, the external technology, this ecosystem we're building is definitely based on XML messaging.
And so for application programmers, they can just continue doing the same sort of things they've been doing all along. They've been dealing with web services, and now they're just adding things like support for Indigo on top of that. Now, would that take the place of things like MSMQ, or working side by side with it?
Well, so it's really interesting to look at MSMQ today, right? If I'm out in the world using the Microsoft platform. I'm definitely using some queuing technology in increasing numbers. I'm using MSMQ. MSMQ is great in a Windows-only world. It's definitely a Windows-based technology. And for enterprises that have decided to go 100% Microsoft, God bless them, and MSMQ would be a wonderful substrate. But quite often, people have, perhaps legacy systems or tomorrow's legacy systems that won't be Windows-based. So MSMQ, all by itself, probably isn't the right substrate to use for all of your integration. That stated, it definitely gives us great value. It gives us durable messaging, transacted messaging, things we don't get today with ASMX. Going forward, what happens is a lot of the functionality people today get from MSMQ, transacted messaging, durable messaging, are core features of Indigo proper. So really what happens, over time is that ASMX programmers will have a very, very obvious and easy transition to starting to use Indigo. We completely are compatible with that programming experience. But it becomes fairly easy through attributes and config to start turning on features like transacted messaging or durable messaging. And so I think what happens is if you're a programmer today and you know ASMX, you're in great shape, right? We just add a few more attributes conceptually to make that a richer experience. And if you're an MSMQ programmer, we also support the messaging style programming in Indigo. But today you kind of have the two worlds. And the nice thing about Indigo is unification.
Yeah, one of the things that Steve Schwartz, one of our folks on our team, he likes to often say is that the goal of Indigo is for that if you use an existing distributed technology or existing connected system technology that Microsoft ships, MSMQ being one, COM+, ASMX, that you feel when you upgrade to Indigo that it's just V2, that your way of thinking about the world was the right way to think about the world. But you get all the features of rich interoperability and all these service features that are available to you. And so so if you're getting ready today to prepare to move forward with Indigo, if I want to build a connected system today, as I said, ASMX, first-class technology, that's the way to do it. And when Indigo does ship, it's going to be a very natural extension for you to move forward to the Indigo model. And in fact, we spent a lot of time thinking about, if I'm an ASMX developer, how do I think about the world and how can we make sure that the Indigo concepts are very, very similar and the migration is very quick. In fact, we call it the cookbook migration. We want somebody to be able to sit down, look at a cookbook, and be able to very easily move up. But the beauty of Indigo at the same time is that you don't have to do anything. Even if you didn't want to migrate your code, you can just add a new service and have your existing ASMX services and ASMX clients communicate with that. That's the beauty of protocol integration. That's the beauty of utilizing XML messaging, is that, you know what, if you never want to upgrade that code, you don't have to.
And it sounds like also that level of evolutionary integration is something means you guys have spent an awful lot of time thinking about the right ways to implement some of these technologies. What are some of the thought processes and guidelines you've been using internally for understanding what is a connected system, what do they need to do, and how do we take in a system in accomplishing that?
In trying to figure out what the overall programming experience would be and what the administrative experience would be for Indigo, we spent a lot of time, doing navel gazing based on our old, our existing technology stack. And what came out of that exercise was this list of 4 tenets that we use to influence the way the programming model works, the deployment model works of Indigo. And those four tenets are that, first and foremost, boundaries are explicit, right? The fact that I've opted into making something visible in this service ecosystem, is something a developer has to take seriously and has to opt into. And honestly, it's something an administrator also needs to opt into and take seriously, right? And a lot of the it all just kind of is magically visible on the network attitudes that a lot of the industry has had. And, we're as guilty as the next party. We want to have a much more deliberate system where things aren't visible, things are not accessible, nothing works by default, right? Which is kind of a very coarse way to say it. And that I opt into having a service facade. I opt into taking data types, operations, behaviors, and forcibly, as a developer and as an administrator working arm in arm, make those things visible to the outside world. So boundaries are explicit is number one. Number two is that services are autonomous, right? the fact that you can reboot the internet, or you can't reboot the internet, yeah, the fallacy.
Don has tried to reboot.
Yeah, I've
the
tried
internet.
many times. The fallacy that you could reboot the internet or that you could reboot your IT organization, it's a fallacy. And the observation that, it's really one big program, and that individual services are autonomous entities that have distinct organization boundaries separating them, that often have distinct developers, distinct deployment, rollout schedules. The fact that there's going to be code out there that's going to stick and be there for a while turns out to be important. And certainly the way we think about versioning is that, once I deploy a service, I may not get a chance to change it, right? We may reorg, we may, sell or buy aspects of our organizations. That piece of code is going to be there, and I need to be able to live with it for 20 years, right? And that's a big deal. So the fact that these services are autonomous and they have to not only be deployed independently, but they're often secured independently. A lot of the investments we made on the technology side have been in making sure that we have a security infrastructure that works across organization boundaries and that works across many different technologies. So the third tenet, which for me as a comm guy was the most interesting one to look at, was that the integration point between two programs isn't based on classes, right? In the 1990s, we tried to make distributed objects the metaphor for gluing together enterprises and gluing together all kinds of different software. And what happens is when I have a single type, a class, that conflates both state and behavior, right? These two largely disjoint facets. I have this data type that I'm going to send you some data, but you have to have my code to interpret it. And we get into a very, very weird, almost mobile agent style deployment situation, which again is a very, very hard thing to scale. It's a very, very hard thing to live with over, a multi-decade life cycle. So this notion that services don't share classes, but instead what they share is either behavioral contracts or structural schemas. In fact, they share both, but they're always distinct. That was a huge insight, and it really kind of came out of watching people using the various technologies that we've been shipping. And certainly the .NET remoting customer is very accustomed to sharing classes, right? That's the metaphor. The .NET remoting is kind of the last big distributed object technology from Microsoft, right? And ASMX users, which shipped it, ASMX and .NET remoting shipped simultaneously. And it was just a wonderful petri dish of having, these technologies out there and watching people use them. And the fact that ASMX users always shared things that were either purely structural schemas or purely behavioral, which were the WSDL contracts. And it worked, and people liked it. And it was actually fairly easy to live with. And can we do better? Of course, but it was amazing insight. And so that really kind of became one of the rallying cries for what we do in Indigo. And then finally, the fourth tenet is the fact that if I'm going to look at two services and determine if they can work together, I'm really going to look at these policy assertions, right? It's not so much that I care, do the schemas match? The schemas have to match, but that's often not sufficient, right? I also have to have these stable, universally understood names, like this will use X509, or this will use atomic transactions, that I can use then to determine whether these two pieces of software will work together. And so really these four tenets: boundaries are explicit, services are autonomous, we share schema instead of class, and then we do policy-based compatibility. Those are really the four ideas that we think we're going to be living with for a long time, and they've certainly served us well for a while now.
And it sounds like the same sort of concepts that the developers in the audience should be thinking about while they're writing their applications.
Absolutely.
Because they don't just apply to how we develop the infrastructure, it applies how they develop the services.
But believe me, those four tenets are as much about guidance to people who want to write these systems that are reasonable to live with, as it is for us to drive how we build the technology.
But I think over time, the key thing that we're trying to provide to developers is that these are the four tenets that we explicitly build into the architecture. And so that all of our tools and all of our frameworks take care of that work for you. A lot of the things that I try to do, and I know Don tries to do this as well, is that if you don't want to think about these things, if you just want to think about running your business or connecting systems that you already have, Microsoft provides you a framework and a set of tools that lets you worry about your business. and allows you to sit down and think about, how do I want to run my business process? How does my organization work effectively? And then to utilize our tools to give you the architectural purity that you need and to follow these tenets. And so Indigo out of the box is going to embrace these tenets, and it will be very hard, if not impossible, for you to violate any of those tenets because we've baked it directly into Indigo. And so I think that's a key thing from us. We're not doing our jobs if you have to think about all of these things when you architect your systems. Now, certainly, because we haven't shipped Indigo yet, we haven't got our tool story lined up with all of these tenets, you're going to have to think about these things today, but we're working very, very hard to make sure that's baked into the architecture moving forward.
Mm-hmm. Now, if that's baked into our architecture on our systems, how does that apply to connecting to non-Microsoft systems? Is there going to be issues there involved, or just the fact that people are thinking in the right fashion, any code they write on a non-Microsoft system will also have those same capabilities?
Ideally, it would just work, right? The reality is, if you work in terms of these principles, it's easier, right? It's faster to do it. It doesn't mean that it's automatic, right? Even if in a purely Microsoft-based world, there's still effort, right? You can design in terms of these principles, but it's still going to be labor involved in bringing two pieces of code together. Right?
If it's easy, it wouldn't be fun, right? Yeah.
We want it to be easy enough. But certainly, we're not into a world where we have AI driving all of the integration, and we can push a button and things.
But Don is working on that.
We'll see. But it's just easier, right?
So is the connected systems concept, is that something that you think is important to almost all applications, or certain classes of applications?
The code's worth writing. It's worth reusing, isn't it?
Yeah.
Right? Why would you write a program that you're not going to use again, right? You kind of, part of the thrill of writing programs is that someone might use them, right? Some people, I guess, love to just write programs for their own personal satisfaction, but most of us get paid to have those programs add value, and often there's two ways to add value, for a program to add value. People use it or other programs use it. And the sweet spot is to get both, right? And that's why a lot of the .NET technologies really are focused around both of those aspects, right? The fact that ASP.NET and ASMX are so tightly integrated means I have a single programming system for not only doing projection-based UIs over HTML, but for doing these programmatic interfaces using XML messaging. That's a really sweet spot to be in.
When I think of connected systems, I think of client-server sorts of things. So I've got my machine, and off in the distance, someplace is a server that is, running ASP.NET, it's listening for web service requests and stuff like that. Does the concept work on one machine? So if I'm running on a disconnected machine, can it also be getting value from a connected systems model?
I think that there may be two questions in there. One question may be a scenario in which I, say, doing Salesforce automation or something of that nature, where I disconnect from the network. I do some sort of work on a very smart client, and then when I reconnect with the network, then the work that I have done is automatically updated, communicates with the services. So there's that aspect, certainly. There's also another aspect when we talk about utilizing services on a single machine, that multiple processes taking advantage of this. A classic example of this that from the COM days of Don is Word and Excel. Those two things communicate with each other, and they communicate with each other by sharing class, by violating some of these very tenets that Don was speaking about. And that's okay because, well, it's okay in some respects because they're both from Microsoft, et cetera. But imagine a world where Word and Excel were by separate companies. And then I wouldn't want to be sharing class. I'd like to establish or follow the tenets that are available to me in terms of the services that Don is talking about. And so we see Indigo as being a technology to address both connections across these services like we've talked about, also being utilized as a technology to allow disconnected clients that we've talked about. And lastly, being a technology that allows two processes to communicate with each other in a service fashion as well.
And so does Indigo aid in that? I mean, does Indigo aid in local processes communicating back and forth, or is it just, again, for a client and server sort of model?
No, it's definitely, certainly a broad application is distributed computing, cross-machine integration, but I think Indigo, even in our V1 release, will be used a lot for local process-to-process communication. The interesting test will be, how long will it take us to take this? So let me take a step back. With distributed objects, what we tried to do is take a local idea and stretch it, and we stretched it until it snapped, right? And it snapped because the metaphor didn't match. What we're doing with services and with Indigo is taking a metaphor which we kind of assume high latency, variable availability and reliability. And what we're doing is, it's really kind of an experiment of how much can we shrink that? How small of a form factor can we make that work in? We're confident we can make it work cross-proc in a way that's competitive with other technologies, that it would be a completely reasonable choice. What'll be interesting to see is how long it takes us to get to where we're actually using it within a single process, within a single app domain in the world of managed code. Because really what Indigo is about is as much about a metaphor for integration as it is about some DLLs that we ship. And so yeah, I think local on-box is certainly well within scope for what we're doing in Indigo V1. And the performance wall will be the interesting test to see how far we can go within an app domain.
So it's kind of like, Indigo is network topography agnostic, even to the point where there is no network topography available.
Yeah, absolutely. Absolutely.
Now, what do you see as some resources for developers that are interested in better understanding how they can develop connected systems applications? Where should they be going for information? How should they be understanding and thinking about it? A lot of people in the audience, I'm hoping, are listening to us and understanding that I need to start doing some of that sort of stuff in my application today. What should they do? Where should they go?
Well, I think they should go to your home at MSDN. I think MSDN is probably the best resource in terms of Microsoft technologies to really understanding how one can utilize Microsoft technologies. Richard, who will be on a little bit later, I understand, has a wonderful blog where he talks about lots of connected system issues. Blogs are a wonderful source of information. A lot of folks on the Indigo team, including Don and myself, blog quite a bit about these sorts of things. But Richard really highlights many times a lot of the guidance that we provide. And how to think about connected systems in terms of the existing technologies and then migrating that up to Indigo. So MSDN and of course all the blogs. And there's several wonderful books that I imagine Don has better visibility into than I do that folks could look at as well.
Yeah, certainly the Martin Fowler series of books is really wonderful for getting people's heads into this space. And I can't recommend them highly enough.
Okay. Well, thanks for joining us. I'm sure our audience got a good idea of what connected systems is and how you guys are playing a part in allowing them to develop connected systems applications.
Great, enjoyed it.
Thanks.
So hopefully that gave you a good introduction about what connected systems are and allows you to wrap your head around thinking about how your application can take advantage of that. Now, following this brief break, we're going to come back and actually take a look at some connected systems application coding so you can actually see it in practice.
Okay, kids, here are the stats on Joe Java.
Java, that is so 90s.
Yes, height 6'3". Ooh, very strapping. Lines of code per day 10.
Squeeze me. Repeat after me. Unproductive.
Mission career advancement.
Java and Linux. Become a .NET. Take us away.
Please, let's go save Joe Java.
Let's do it.
Oh my goodness. Oh no.
Who are you? Okay, let's get busy. We've got servers to configure. We've got test scenarios to run.
We've got code to look at.
Oh,
Hey,
you change your life.
you're the left three.
He's a genius. He's a genius.
Be a lamb. What is this?
We have much to do. Let's get out. Keep them going. Welcome to the Microsoft platform.
Wow!
Sit him down.
Toto!
Joe.
Toto!
Right here. Let's be honest. How many pounds of unused UML diagrams do you have in your desk drawer?
I have been putting on some extra weight in my design center. I mean, I've just been trying to be rational, you know?
Oh, that's adorable. Listen, the key to have your designs come alive is to link them to your code throughout the application lifecycle. Here in the lab, you'll not only learn about design best practices for .NET, but you'll also get all the information you need about the would-be lifecycle tools that'll help you come up with designs your whole development team will love.
Wow.
Love, 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 love. You're going to be the hit of the dev party. What will you wear?
You.
Listen, we can't hang around here designing all day.
Here, have a seat. Now, first things first, when is the last time you had a good night's sleep?
Times are tough. You know, I can't get everything done during the daylight hours.
Hey, that coffee code and the penguin toys, those are for little boys. You are a serious dev, and you need a serious platform.
Yeah.
Here at the lab, we have everything you need, all the tools so you can turn over that new leaf. And then, here, you can code up a storm with all the comforts of home. Then when you go back to your office, you'll have such a head start on your work that you'll have some extra time to do, I don't know, maybe some clothes shopping. Get some measurements.
Yeah.
Come on.
Hey, where are we?
You're no longer in the dark. You're using .NET. Gut check time. How many of your projects have actually been deployed?
All right, you got me. I mean, it's really hard to worry about those deployment scenarios when you're so busy coding.
I feel your pain. How are you supposed to code and think about test and deployment all at the same time?
That's exactly it. How are you supposed to do that?
By using the right platform and tools, that's how. Visual Studio helps you build applications that are a snap to deploy. And your IT manager will love you. So, before you leave the lab, you'll have everything you need to test and validate your design and prototype. So you'll actually have something real to show your boss when you get back home.
Oh, wow, that would be wonderful. I mean, I'd love to get that guy off my back.
And now, let me introduce you to a little thing that we call fun.
The Microsoft Platform Lab is so fantabulous, it even has an Xbox.
Wow.
Yeah.
Okay, now we have to run. We have another developer in need that we must attend to. Oh my goodness! Girl, come on, get in there.
Oh, this is absolutely wonderful. I don't know how I can thank all of you.
Miss him.
So proud.
All right, let's see how this goes.
I am so nervous.
Oh, I'm a wreck.
Oh
my God.
Look at him.
Oh,
That's great. He looks so much more productive
yes,
now.
he does. Oh, his bug rate is very low.
.NET rocks.
That man knows how to write code.
If only everyone knew about the Microsoft Platform Lab at Building 20.
Amen.
Here's to the Fab Lab.
Oh, genius.
Welcome back. Now, in the previous segment, we talked about the architecture of a connected systems application, what it is, and how you need to kind of think about architecting your applications, your legacy applications, and your soon-to-be legacy applications to fit within that world. Now, in this segment, we're going to take and actually show some code to illustrate how applications can be written to support the connected systems model. And to talk to me about that, I have Eric Schmidt and Richard Turner. Thanks for joining us.
Thank you.
Now, why don't you just let us know exactly who you are, what you do, and why connected systems are something that you guys are excited about.
Sure. I am the technical evangelist for web services inside of the platform developer and platform evangelism team. So I pretty much spend all my time talking to customers, both systems integrators, ISVs, and enterprises, advising them on how to develop service-based applications and to take advantage of the web services infrastructure inside of the Windows platform. So I have an extremely vested interest in talking to as many people as possible about this technology.
So you're not only excited about connected systems, you want to get other people excited about it as well.
Exactly.
Yeah. Okay.
Hi, I'm Richard Turner. I'm a program manager on the Indigo team, and I've been involved over the last 8 months or so now in communicating what our recommended guidance is, for example, on how to go ahead and build services today using existing technologies, and how to prepare for the introduction of Indigo when we eventually get to ship it.
Mm-hmm. Now, Doug and Don kind of covered some of the the basic concepts and the overall mindset of what a connected systems application is, who should be using it, and what they do in designing the infrastructure and the architecture that connected systems applications can be built upon. But a developer in the audience really wants to kind of see, you know, when the rubber hits the road, you know, what do I need to do? What do I need to understand? What do you think some of the core concepts are that a real in the trenches developer needs to think about in order to enable their applications to make use of this connected systems model?
Well, some of the main concerns that we hear voiced from developer community, both internally and externally, are really relating around a couple of very key issues right now. One of the key issues is interoperability. How do I build a service today that is consumable across the broadest range of available technologies so that my investments are leverageable and I can get a decent return on the investment I make when building a system? And the other side of things then is, okay, if I decide to go ahead and expose my services, my systems, to as broad an audience as possible, then how do I do so in a performant manner? How do I ensure that I reach my performance goals, that I'm able to deal with the scale and demands of the platform places upon me when I make my choice about which platform to support?
Mm-hmm. And Eric, what are some of the issues you see people dealing with out there?
From a developer perspective today, some of the key issues that that are asked of us is they need to understand the continuum of technology that Microsoft offers today. So of course we've made significant efforts around engineering and developing a well-factored programming model for web services development, specifically with the .NET framework. Subsequent to that, we've built a product called the Web Services Enhancements, which enables developers to adopt emerging web service specifications. And of course, we have BizDoc Server, which is a tremendous technology to help drive business process on top of the service investment that folks are making. And then in the future, we have Indigo, which Doug and Don talked a bit about. And from what I hear and dealing with developers, that's probably the most important ask is, what is the strategy around those four technologies? When do I use them? How do I migrate and ensure that I can interop as I go through this transition period through these various technologies?
Mm-hmm.
And that's kind of what one of the themes that Richard and I want to talk about today.
Because that's what connected systems is all about. We're not talking about partially connected systems, we're talking about connected systems and being able to deal with that from an interoperability level, from a legacy model, and from a transitioning period and moving forward into Indigo and beyond. I think that all wraps up into the same thing.
Absolutely.
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 So what are some of the code demos you've got prepared for us to illustrate, what a connected systems application is all about?
Yeah, the first thing that we wanted to talk about was the interoperability piece, and specifically, kind of echo off some of the guidance that Richard's team has developed in this space, specifically about how to enable interoperability in making certain design decisions whenever choosing the technology that you are going to use to build a service.
Mm-hmm.
So I don't know if you want to talk a bit about.
Yeah. It's probably worth discussing very briefly for a few minutes the whole aspect of interoperability. Interoperability isn't just about being able to call, for example, a service on a Microsoft platform from someone else's platform, maybe IBM's, maybe BA's, for example. It's also about how to leverage existing deployed componentry and services even from within our own platform. If, for example, I have a team of developers who are primarily geared towards developing enterprise service or COM+ applications, the problem with this is that the only people who can really consume those applications are other developers who understand how to develop COM+. And if I have another team in another part of my business who are primarily ASP.NET developers or ASMX developers, then how and what hoops do they have to jump through in order to be able to write code that uses my services effectively? So there is a matter of interoperability within our own platform as well as interoperability on a broader scale. Now, the whole industry is starting to move down the path of adopting what we now call web services, which very shortly, hopefully, the term web will disappear and they will just become services as the ability to transport packets across different protocols and across different mediums becomes prevalent. So we have the ability to start thinking now about how we start developing systems in the future. And it seems to be that the entire industry is now geared towards delivering services via open standards-based protocols and technologies. And in fact, if you look at the work that IBM, BEA, Microsoft, and others have been performing in building these WS standards in particular, it illustrates very clearly just how important the ability for different systems to be able to communicate whilst not or whilst fully supporting security and transactions and reliability, and now also encompassing more advanced concepts and features such as policy negotiation, etc., etc. So the whole industry is now moving down this path of using what we call today as web services, but adopting some of the newer technologies coming down the path, some of the new protocols on the wire, and that's really where we are going into the future, and that's what Indigo is primarily geared to do.
Mm-hmm. Mm-hmm.
Yeah, so one of the first things that we want to demo is kind of just some foundational pieces is specifically around hitting home the importance of interoperability. So Richard and I like to use the example of can you speak my language? Do you speak the dialect that I can understand? And there are obviously a myriad of choices, both inside the Microsoft technology portfolio today that I could build some type of service-based application, and definitely outside of the Microsoft portfolio. If you go pure messaging, or if you go some type of hybrid XML based protocol that's not based on web service standards, then we run into an interoperability problem because we're not speaking the same dialect. So in the first demo, we basically just want to kind of go back and foundationally look at what should developers be doing today at a base level whenever they start to develop services to ensure interoperability today and in the future.
Okay. Yep. Okay. And this is one of our key pieces of guidance. We have a number of pieces of guidance that we're shortly going to be publishing in paperwork on MSDN. But the first piece of guidance is to write as much of your code as physically possible in .NET, and to expose that code using ASMX wherever possible. By exposing your services using ASMX, you are already getting, if you like, for free out of the box, a great deal of interoperability. You're getting a very stable runtime environment. You have security, or you have the ability to secure your services using, for example, web service enhancements, which enriches your ASMX web services. So one of the primary guiding principles that we have right now is when customers say, which technology do I use to implement services, is to implement services wherever possible using ASMX. And we just wanted to demonstrate very quickly just how simple it can be to host a service in ASMX.
Okay.
Great. So what we're looking on the screen here is just an artifact of creating a new ASMX or ASP.NET Web Services project. We come up and it'll stub out a quick hello world. I changed it to make it a little bit more personal for this discussion, so it's now hello Robert. So we have the starting point, a design service to start creating a service that would be exposed. And the first question is, well, what types of information is my service going to be interacting with? So this in lies starts some of the interoperability discussion. So whenever we talk about information, data that's going to be sent out on the wire, how is that data going to be encoded? At the beginning of the web services history, there was kind of two different thoughts on encoding styles for creating web services. And through different industry efforts, specifically the Web Services Interoperability Organization, the industry as a whole has kind of settled down on that document style and then literal encoding of information, which is really based on the XML schema protocol, is the best way to achieve interoperability. The nice thing is that out of the box, ASP.NET Web Services leads you down that path. So what I'll show you quickly is over here, I've created a class, which is something that you would logically do whenever you're building any type of application. You start building up some type of class and object model to describe the behavior and types of information it's going to process. So here I've created a new class. I've called it my type, and it contains one public member called foo. And we'll go ahead and just change this to person name. And we're also going to change the namespace. So above my type, I have an XML root attribute. This is part of the .NET Framework serialization technology. What this enables me to do is enables me to provide a namespace so that I can privatize my data. so that whenever my service is interacting with information, it's specifically looking for information that is typed against this namespace. So we'll change this to something like, you know, Eric's namespace. So now this information is associated with me. This is also a way that I can aggregate version information in the future. So we'll go back over to my service, view code, and you see that this method right here, hello Robert, is taking as an input the parameter of my type. So on the wire, whenever I go ahead and start up the service, it's going to expect to see some information that is contained in that class model that I just showed you. And fortunately, hopefully everyone that's watching the show knows the power of building web service inside of ASP.NET. It's as simple as adding a web method attribute to this. What this ultimately does, we'll take this class, and we'll go ahead and compile this to reflect changes. If I go ahead and browse, what we're going to do is, by default, as a Max infrastructure, we'll create a temporary page to show the service description and also invoke the web method that we created. So if we go and look at the service description, now we're into the interoperability and standard space. So going back to what Richard was talking about is, okay, what are these standards? What are these protocols that we are going to agree upon in order to have interoperable messaging? And whenever we start looking down inside of this WSDL file, you'll see a type section. And you can now see that the manifestation of the class that I created before, my type, qualified by my namespace, is now an XML schema artifact encoded inside of my WSDL document. So anyone that wants to consume the service that understands XML schema can walk up, consume this WSDL, and know how to interact with me in an interoperable mechanism. And the power behind this is I didn't have to create the WSDL. I didn't have to create the schema. It's inferring that information and typing system from the class that I built that I'm used to and comfortable inside of inside of my development environment. This is one way of developing services. So I can go and I can create an object model that will drive in essence, my contract. In the Visual Studio 2005 timeframe, we're also going to be providing what is referred to as a contract first programming model. So I could take something such as a WSDL contract that will then flow down into the actual implementation of the service and how I would go about interacting with it. So we can kind of look at two different views of the world, whether you want to start with contract first or start with your type system first to build up your service, depending on where you're at in your development process. So the key takeaways from this are, out of the box, we give you the ability to build interoperable web services specifically around the concept of data serialization and how that information gets typed inside of the message. The closing point to this is, make sure in the full spirit of disclosure, there are some things right now behavior-wise in Visual Studio 2003 that we don't do correctly in terms of the WSI basic profile. However, if you go up to the MSDN architecture site, we have a set of guidance that enables you to create out-of-the-box interoperable WSI basic profile compliance services. That issue is solved and fixed in the next version of Visual Studio.
So, the main point here is that by using the WSDL model, by having that reflected against the code you wrote, that's what allows a developer in the outside world to see into the code you wrote without you having to actually hand them the code, show them the different types you have, show them the different strings you have. They can use the WSDL for understanding all that, and that's where the interoperability comes in.
Sure, and I can, we could continue down for several hours, creating some type of type system that, was not only privatized for how I wanted the application to behave internally, but also, externally exposing something that is the actual essence of data that I want to expose on my service. So it's a way for me to completely control the type of information flowing in and out, but doing it in an interoperable mechanism.
And it's a very important point to note is that when you're building services, especially moving into the future, that what lies behind the service boundary inside your service is largely a black box to the outside world. If you implement services according to the guidance that we're going to be publishing, then your service will talk to the outside world using a published schema, using information that can be used by other parties, third parties, different platform vendors, for example, and to be able to build client-side applications that can, or calling applications, that can interoperate with your services very easily and very cleanly. What happens inside your service, quite frankly, is completely your own business. I don't get to see what's inside another service if all I'm doing is exchanging SOAP messages or XML messages via some agreed format and protocol. So whatever you do inside your services is largely hidden from the outside world.
Okay, thanks. And then what are some of the next stages we need to think about for connected systems applications?
Well, one of the so we've already discussed the first piece of guidance, if you like, in terms of building your services using ASMX wherever possible. But then the discussions about what do you do inside your service, which of our other technologies do you use and in which scenarios, is probably one of the most hotly debated and contested discussions around right now. Now, we have a very rich, very broad set of technologies that have largely evolved up until the point where we are today. Indigo will be superseding the capabilities of most of the existing technology stack that we have for building distributed systems. But until Indigo comes along, what do we use? How do we start going about building services? Now, we've discussed the first 10 in terms of ASMX, but there are two other core technologies which I'd just like to very briefly discuss. One of which is enterprise services, which is the .NET wrapper over the top of COM+. It's important to point out for those that haven't been exposed to this stuff for a while maybe, is that COM+ is not really about COM. COM+ is essentially a set of services that spins up and shuts down and manages the lifetime of components that you can host within that environment. It also provides services to secure, to manage, to deploy, and so on, these components in your environment. Now, the important thing to note is that you can write .NET code and write components in .NET that can be hosted inside enterprise services framework, which is then hosted inside COM+ when it comes to runtime services. So I can go ahead and I can build enterprise service components today that are hosted inside COM+, that can interoperate cleanly with existing native applications, that can utilize existing COM+ investments, and that can provide great value to my existing infrastructure. In Indigo timeframe, it's worth noting as well that if you are building enterprise service components, that your investment is protected to a large degree, because we're doing a lot of work in Indigo to teach COM+ to speak Indigo on the wire, so that your existing components can be exposed to other Indigo services, easing the adoption and migration of Indigo as an incremental kind of thing rather than as a chop and change replace. So implementing services, implementing componentry inside your services using using enterprise services is a very, very wise thing to do if you need its rich services, if you need to do things like distributed transactions, if you have complex componentry that you need to integrate into your services implementation, then enterprise services is a great way to go, and it's a great technology to use for those kinds of scenarios. It shouldn't be misunderstood that enterprise services, that ASMX, for example, is only applicable at the outside boundary of your service. You should also consider using ASMX inside your service. If, for example, I have a web service which exposes a method, and all that method does is connects to a backend database, calls a stored procedure, for example, and then comes back out and returns without doing much else, then one could argue that it's maybe overkill to have the ASMX code talk to a COM+ component that then talks to the database and then comes back out and just reverses down the path. The other way of thinking about doing that is to use ASMX code to simply start up a transaction. You can declare your ASMX services as being a transaction if you wish. Although they can't flow transactions across them, they can flow transactions into technologies such as COM+. And I can then invoke a call into a stored procedure inside a database within the context of a transaction. and minimize at least a process hop, if not a machine hop, if I'm distributing components across my environment. So you can get some performance improvements from this, and you get a great deal of simplification when it comes to managing your systems and writing your code as well. So enterprise services is a very, very important piece of the picture. Combined with ASMX, it provides a very powerful distributed systems framework and platform. The other thing to consider, however, is remoting. And there has been a great deal of discussion of late around when remoting should be used, when it shouldn't be used, etc., etc. Now, the thing with remoting to remember is that remoting speaks either its own binary encoded message format on the wire, or it speaks SOAP. The problem with remoting SOAP implementation, however, is that it uses RPC encoding, which was the de facto standard several years ago when we first released remoting, which Eric mentioned earlier on has now been replaced with document literal encoding. This means that even if you were to expose your remoting service using, for example, HTTP and using SOAP encoding, it still would have limited interop because the industry is now moving towards document literal and the two formats just collide. So if you're going to be implementing remoting code, and your assumption is that because I'm simply saying I'm going to expose my service using SOAP encoding, that it will therefore be interoperable is a false assumption to make. So whenever you are considering implementing web services, primary guidance again is to use ASMX and not to use remoting for that service. Now the other thing that people often say they use remoting for is because it's quick. They say that remoting is a very, very high performance technology. And remoting is very high performance technology. But if performance is your primary consideration, it should be very well understood that DCOM as a wire protocol, and therefore if you're using COM+, for example, which speaks DCOM on the wire, is a significantly more performant technology than remoting is. So if performance is your primary concern, you will get typically much, much faster performance out of COM+ components talking across a process or across two machines than any remoting code that you could possibly write. So we'll be covering all of this in these white papers, as I've mentioned. If you keep your eyes on my blog, you'll see details of when they're published. But the story of remoting is good, however, where you need to, for example, integrate legacy systems or legacy wire protocols or legacy message formats on the wire, because remoting gives you very, very good access to the message as it comes off the wire or as it is just about to hit the wire. So if you, for example, need to integrate with, let's say, a mainframe, which uses a particular, let's say, comma delimited data format on the wire, then you can use remoting and you can implement a translator to translate messages back and forth from this proprietary protocol back into SOAP, so it passes back up the rest of the .NET framework stack cleanly. But it enables you to write these translators and formatters to support custom wire protocols. So for those scenarios, remoting is great, but for the vast majority of enterprise scenarios, we strongly recommend using either ASMX or, if you need it, enterprise services instead.
So Eric, do you have any other demos that kind of illustrate some of those features?
Yeah, so what kind of the kind of leading off of Richard's discussion right there is we want to kind of talk about, it's great we can achieve interoperability, but compatibility is the next topic that we want to demo and talk about in relationship to these technologies. So, on the boundary, I'm using, ASMX to achieve interoperability. But then there are certain decisions that I have to make to, ensure that I am going to be compatible with the services that I want to interact with or people that want to interact with me. And also, we'll just pick one topic that we wanted to talk about was the aspect of security. So, Richard talked about, hey, maybe we have to do some translation of data type to talk from SOAP to tab delimited, but you also may have to do some type of translation from a compatibility aspect to do, I need to be able to be compatible with a certain security model versus the security model that I have. So that conjures up several, architectural and design issues as to if I do choose a model, which one do I choose to achieve compatibility, and specifically how would I go about enabling a security model for my services that can flow both at the boundary level and then downstream to other subservices inside my boundary.
Yeah.
So what we're going to show in this demo is another piece of technology specifically, it's called the Web Services Enhancements for Microsoft.NET. The purpose of this technology was to provide kind of a fast access to emerging standards around building service-based applications. So specifically the standards that have been built up through the web services architecture stack. So things like WS Security, WS Secure Conversation, WS Addressing. And what I want to show in this demo is basically three things. I want to talk about how to achieve compatibility through a concept called policy. I want to show how to secure the service in a fairly efficient manner. And I also want to show some extensibility aspects. So going again back to the comment that Richard made about, hey, if you need to do something that's kind of out of the box or that's different, than the functionality out of the box, how do you go about extending that, and what are the extensibility pieces? So what you see here in this code window is in essence the service or server that's going to be acting to process some behavior. This is in essence a very rudimentary chat application. The server has two methods on top of it for the service. One to kind of log in to the service to provide a security layer. The second of which to interact with the service and start chatting messages. The first thing I want to show is in this line of code. Whenever the service starts up, I'm going to be using a configuration mechanism for this service to add an extensibility point. So the Web Services Enhancements is basically based on a filter pipeline concept where I have the WYSI provides a pipeline of pre-configured filters that will run to process certain types of behavior. One of the core features was to be able to process the WS security protocols and have the appropriate interoperable behavior. What I'm doing here is I'm going to add via this configuration line, so I'll scroll over just a little bit, there is a filters collection.
It's kind of a long line of code there.
It is a long line of code. And there's an input filters collection. So going back to the concept of WYSI has a pipeline, it has a pipeline that will run as information comes in on the input side. And if this is some type of request response or response coming back from the service, there's a corresponding output filter. The reason why I'm specifically doing this, and Richard asked before we started, he was like, hey, it'd be really great if we had netmon or doing some type of trace so we could see what's going on with these messages. This is exactly why we did this. So the extensibility piece here is that I have added a trace input filter. It's going to be pushed in at the very top of the stack. So the first thing that happens before any type of security mechanism or deserialization or marshaling of this message, we're just going to dump this message out to this trace input filter. So I go over and I look, and the trace input filter is something very simple. It has one method called process message. The WYSI will say, hey, I have a new message coming in since we're dealing with it from a message-oriented perspective, and I'll just dump out the contents of the SOAP envelope to the window.
I think it's a very powerful thing to actually illustrate is just how simple it can be to write your own filters so that you can get access to the message itself and do whatever you need to do with it.
Yes, this is an extremely powerful extensibility piece. You asked about before, what are customers asking for? This is, a great feature that people have really rallied behind because they're adding all types of things like creating custom filters for doing distributed authorization, or this is a great interception point to do some type of business activity monitoring. So great. So I have this filter turned on, and what I'm going to do is just go ahead and run the demo and see what happens, see how it's behaving. And in some of the other things I'll point out is, in this demo, we're using the web services enhancements. In WYSI 2.0, we have the ability to host services inside of pretty much any type of application domain. Here, we're hosting inside of a console app, and we're speaking TCP. We're speaking SOAP TCP. So this is another kind of highlight of some of the advanced engineering that we've done around this programming models to give you the ability to host services outside of just a straight IIS HTTP bound environment. So I have one service listening on this address point here, and I'll go over to my client, start it up.
So there's two separate applications you're running now.
Yes, so I'm just running two console applications, and the client will start up, send a message over to the server, and here you can see the artifact of my input filter running. So this was the raw message on the wire as it came through before WYSI did any type of security processing to it. And so what you'll see here up at the top, you'll see some addressing information, which includes things like the action. So where is this message really to be destined and routed to? You'll see some information about message identity. So if you want to do some type of correlation, et cetera, on this message. And then as we keep going further and further down, we get into the security section.
So all of this is the WYSI 2.0 SOAP headers that are packaged around the message that you're passing from your client application to the server in order to get this chat thing bootstrapped.
Yeah, and I will qualify one thing that you said is that these aren't really the WYSI implementations of these SOAP headers. This is WYSI being interoperable against the WS security specification.
Oh, okay.
So as long as someone else is abiding by that same specification, which is available up on the OASIS site, we will have the ability to do interoperable secure communication with these services.
So the server could have been running on a non-Windows machine, programmed for IBM's usage of services and stuff like that.
Sure, we have all types of demos and traction around that space. So what you're seeing here is really, and we'll go back and look at in the code, all this information is, in essence, the XML signature, the digital signature on top of the message.
It's important to note as well, people have said, for example, why do I bother using WS security rather than, I don't know, SSL? And the important thing to note when you secure the message is that that security information or the token that follows it around flows through your entire system until it actually reaches the endpoint, rather than a message that is unsecured being passed across a secure transport. As soon as it reaches something at the end of the transport that then rebrokers that message onto the rest of the world, all of the security context is therefore lost.
Because at SSL, you're securing the pipe.
That's right.
You're not securing the actual packet itself.
Yep. And it's only the pipe between usually the outer boundary of your system and the outer boundary of the receiving system. Once it gets into the receiving system at the other end, that information is usually lost. Mm-hmm. So using something like WS Security gives you a great deal of ability to provide a great deal of contextual information, as well as ensuring that the message remains secured until it actually reaches the target endpoint itself, rather than the edge of the system that it lives within.
Mm-hmm.
Yeah, and kind of echoing off of that, the other powerful aspect of this is that at design time, at development time, I'm not going to have to worry about at deployment time, is this thing going to be secured properly? If we're talking about SSL, is the infrastructure going to be set up correctly in order for my service to behave? Which leads me into the next thing I wanted to point out about, how is the security model driven? What is the developer experience around using WS Security, specifically in the WSE implementation? And one of the ways that we've implemented security enforcement and security processing is through the concept of policy. And what policy enables me to do is I'm going to open up the policy file here. Again, this is another specification. This is actually an incarnation of WS security policy, which gives the developer a way to articulate at design time the certain types of security assertions that need to be enforced and processed for that service. And specifically, this models the behavior that I just showed you. Here I have an endpoint section which basically points to, okay, what types of endpoints, what services are going to be affected by this policy. So here it's basically flowing over all of the operations that are in the context of the policy scope. And the request side, so the request side has a policy that correlates to X509 signing. So you saw that in the output windows that the client was having to sign that message in order to comply against this policy. And then down here, we can then go look at some more particular information about what is, sign-x.509. What is that all about? And get into specific information like there's a specific token that needs to be used, specifically the type of token. It needs to be an X509 version 3 token. Again, this is a public standard that people can people can comply with. And I could just as easily, go and change these policy assertions to reflect the other things that are available in WS Security. I could say that the policy was the thing's message body needs to be encrypted, or change the token type to a username token or to a Kerberos token. So it's a very flexible model for the developer to assert at design time the types of behavior that he or she wants the WYSI to enforce.
And now, when all this talk about, the security policies and X509 version 3 and stuff like that being included in the headers here, the programmer in me kind of says, oh my God, that means I'm going to be sitting there parsing these headers and figuring out what version 3 versus version 2 and doing all this sort of stuff behind the back. That doesn't sound very easy to me.
Well, that's why you want to use WYSI.
Yeah.
So WYSI handles all that for you automatically.
Yes. And I'll point out something else, is that, creating XML files, angle brackets, et cetera, like that is not the most, error-free experience in the world, specifically if you're having to do it against a specification. So with WYSI, what we also provide you is a wizard to drive policy. So if we go here, I can go ahead and configure the policy that I just showed you. And this guides the developer through a very logical process. So what do I want to do here? Am I securing a service or a client? Here I want to secure a server application. These are some of the advanced features that you're seeing out of this that we're going to skip over in this context. We also have support for things like secure conversation and trust. So to emulate what you just saw, if you wanted to go through the wizard experience, I could say that the message coming through, I want to ensure that there's a signature associated with it, and that I'm going to use an X509 certificate to drive that processing. This window, this just again shows the extensibility of how we've implemented this, is that if you are using certificates, then certificates also have an additional set of requirements. Who do you trust the certificate authority issuing that certificate? But we're going to bypass that for this. And then if I want to then secure the back channel, the response, I can go ahead and encode that as well. So now the wizard basically says, okay, you have a service policy, you're requesting that you want to require signature, and that the X509 certificate token will be the mechanism to drive that. So this is the outcome of that wizard. So not only I don't have to handcraft this, the WYSI will then automatically enforce this at runtime. So we'll go ahead and prove that does work. We'll go ahead and run.
While it's kicking up, it's worth pointing out that policy is an incredibly powerful technology and mechanism for abstracting the actual runtime realities of what security means from the developer's experience, or the notion that my service needs to be secured in some way. So I can, as a developer, say, secure my service, and I'll work out what that actually physically means later. Maybe it's X509 certs, maybe it's some other Kerberos, for example, some other security mechanism. And I can largely write my code so that I don't have to declare that within my code. And therefore, when the security mechanism changes, I don't have to rewrite my application or go and recompile it and then redeploy it. All I have to do is work out some way of distributing these policy files, and boom, I don't have to worry about changing my code, which for most developers will be a great boon.
Mm-hmm. So on the client side here, what I'm going to do to trigger, to ensure that the policy is being enforced on the server side, I'm going to go ahead and comment out this code on the client side. This is basically code that uses the WYSI API to inject a security token, to enable WYSI to inject the appropriate security token, and then to do, in this case, message signing. So I've commented this out. We'll go ahead and recompile. Run. The server is up and running. That policy has been loaded. It's waiting for messages. And if we go back over, the message came through. Now you can see the message is obviously a little bit a lighter weight here, right? The message is a little bit lighter weight because I don't have the security headers in there anymore. And what happened on the client is that we get an exception back from the server saying, hey, whatever you sent me doesn't conform to the policy that it was mapped to. We can do all types of really creative, flexible things. Like we can get down to the actual policy exception that was violated. Of course, you more than likely won't want to be exposing that to the client, from a security perspective. But on the server side, you can do all types of great analytics on, why are people not being able to call into my services, and correlating that to policy interaction. So policy is a great way to enforce all types of different type of behavioral and contract requirements. In this case, out of the box, WYSI provides you the ability to enable WS security with a few clicks of the mouse.
So I think in the conversation so far, we've pretty much covered the first 2 points that we really wanted to put forward, which is around the interoperability side of things. Just very briefly touching on what is the guidance that we're giving to help you write services and develop services that are broadly interoperable. Obviously using ASMX, and as you've seen here in this demonstration, using WYSI to enrich your services and or potentially host your own services inside your own applications. Using protocols that are broadly interoperable with other platforms and other vendors. And then the service compatibility aspect. So interoperability is being able to speak the same language. Service compatibility is about ensuring that you agree on the same semantic terms. We can both speak the same language, but can you come into my house when I'm not here? That kind of idea. So the higher order semantics that we can lay on top of the standards-based protocols, the standards-based communication protocols at least, are where the WS star standards are coming in and going to be providing a great deal of value. I think there's one other key piece that we wanted to touch on as well, while we're on discussions around services and building services today, and that's around performance. Now, I don't know if you've had much feedback from the field and customers around various aspects of performance when considering implementing services today.
Sure. Don't you just buy a bigger computer?
You could. Please do. Yeah, buy lots.
Yeah, and unfortunately, I don't think the buying the bigger the computer is not really solving the issue or getting at the crux of the issue.
Yeah,
and,
absolutely.
And you started talking a little bit about just the performance and impacts of possibly serialization on and off the wire or dispatching. The cost of switching between application domains and things like that, which the guidance that you guys have put together and will be in that white paper is just phenomenal around looking at saying, okay, hey, wow, using HTTP inside of IIS and in the ASMX model, in some cases is just as as performant or more performant than other technology decisions that I made.
Yeah, and this is something that does often very much surprise people. There is a perception out there that because, for example, DCOM and remoting both support some kind of binary serialization upon the wire, that because their messages are much smaller, they're much more terse, they're not as verbose as XML messages, which is what ASMX primarily uses, that in some way means that they are faster to transmit across the wire. Now, that's true to a certain degree if you look at the sheer message performance alone and ignore all other factors. Yes, if you take a small packet of binary data and you squirt it across TCP, for example, it's going to typically arrive sooner than a great big chunk of XML which is posted across HTTP. That's fairly indisputable. But what people tend to forget when examining the performance of systems is that transport is often and should be a very small part of the or the amount of work done during any given method call. And this leads us on towards guidance that we've been actually giving for some time now, many years in fact, especially when discussing concepts of COM+ and MTS before this. And that is that there are few things that will affect the performance of a distributed system more than the network itself. As soon as you stick a network between two nodes in a system, you are automatically going to introduce a potentially large bottleneck in your system. But it doesn't have to be a major issue. If you, for example, were to implement a system which had an interface that was particularly chatty, let's say, for example, in any given logical operation, you had to make a call 10 times to a service at the other end in order to gather the information that you needed, for example, to present on screen, then you would be having to traverse the network 20 times, one for the request, one for the response, and do that 10 times, at least. And we're not discussing security negotiations and things which obviously add on top of this. So you can be going back and forth across the network many, many times. Each traversal slows you down a little bit more. And what we found is that very often systems that are experiencing large performance issues are traditionally, and speaking from some experience, are systems that don't monitor and minimize the number of network traversals that they perform. So one of the pieces of guidance we've been giving for years, which I'd like to reiterate, is that if you're going to implement a distributed system, avoid the network wherever possible. And where you do have to traverse the network, do it as fewer times as possible for any given logical operation. Now this, of course, affects the way that you design the services at the other end. So if I have a service that I've designed, try and implement that service such that I have, for example, methods that might take several parameters, or even an XML document itself as a parameter, that passes to the method all the information it needs in order to complete a number of tasks and then to come back to me. Now, what we've seen during testing, and one of the, we've actually got 3 papers coming out, one of which in particular compares the performance of ASMX, remoting, and enterprise services for like operations. So we have exactly the same mechanism at the other end, and we simply use the different transports to call those operations. Now, what we've seen, and this is something we also saw in the enterprise services perf paper that I wrote earlier this year, is that if we call a method at the service end which performs a significant amount of work, which results in the overall amount of time spent making a call against that service largely consisting of time spent during work, performing work, then the overall time spent during that call, during transport, is very, very small. So if, for example, it takes 1/10 of a second to transfer the message, even if it takes twice as long to transfer that same information back and forth across the wire, if one was to use ASMX, for example, we're only using 1/20 of a second of the overall call time. So the impact in performance of changing to the more verbose, perceived more costly transport is minimal. Whereas if I'm calling a method at the other end that's very, very light and isn't really doing a great deal and responds very, very quickly, then the overall time spent making the call will largely consist of transport time. Now, obviously, if 30% of my time spent during the call is transport, and I then double the time taken to make the transport, I'm now seeing a huge performance impact in my system. So if I was to implement my system to make my methods as busy as possible, to make as few calls as physically possible, then I would obviously be minimizing the impact of transport. And what we tend to find is when a system is architected with this guidance in mind, then largely it doesn't really matter which technology you use, be it remoting, be it enterprise services, or be it ASMX. They all tend to normalize because the amount of work being performed at the service end is considerable. They all tend to normalize down to pretty much within a very close tolerance, at least, very similar levels of performance on the wire.
Mm-hmm.
So that's a really, really key message I want people to really take on board and to start discussing and to start investigating. You know, write test rigs, perform complex logic at the server end, write 10 records to a database, for example, during any given one method call, and then do performance tests against these different transports, and you'll see that the difference in the transports really doesn't make that much of a difference in terms of performance across the wire. However, while individual call performance is important, moving to the web service standard-based technologies gives us a great deal of capability when it comes to, for example, load balancing. If anyone's ever tried, for example, load balancing COM+ components across many servers using component load balancing, it can sometimes be a tricky affair. Whereas if I'm simply using ASMX to expose my service, I simply put a load balancer in front of my pool of web servers, and I now have a very, very scalable solution that can scale out almost infinitely, obviously so long as I haven't implemented services that are stateful. We've been giving that message for some time, and I think most people have got it.
Mm-hmm.
So if I've got stateless services, and I'm implementing them, hosting them in ASMX, and I'm putting load balancers in front of them, I've got a huge scale story that I can talk about with practically no effort, quite frankly.
Mm-hmm.
So there's a great deal of discussion that can be had about performance, but that's really the key message that I wanted to get across. Minimize network transport interactions wherever possible. Only traverse the network where you want to. Where you absolutely have to, I should say. And make the methods that you're calling do as much work as physically possible during any given transfer, during any given method
Mm-hmm.
call. And you should see the impact of transport changes become negligible.
Yeah, and the only thing we wanted to highlight, just from a coding perspective, like whenever you sit down and thinking about the guidance that Richard just talked about, is what am I going to be exposing type-wise? What are the things that my service is going to be digesting and then possibly emitting back out? And it goes back to the serialization piece that we talked in the very beginning. So whenever I go into my code, and I look at potentially creating a more chunky oriented service that's, obviously I could create something if I was going to process a purchase order that was very chatty, create an instance of a PO and keep doing set methods about setting the date, setting the ship to information, adding line items, right? And I'm keep going back across the network. Functionally that may seem like a fun application or something that is logical to do, but that violates pretty much all the guidance that we just talked about. So
it'll work beautifully on the developer's workstation.
Oh yeah, it'll work great.
And then as soon as it goes anywhere near a distributed rig, suddenly falls apart in terms of performance.
Right. So I go back to my PO and I start modeling out all of the things that I need to expose. I need to expose public int ID. I need to expose public name, all types of rich information that is required at a minimum. If I go back to this, to process the purchase order. So that could mean all types of traversals on the back end, talking to the database, going to some type of queuing system, going to a line of business system. Therein lies all the overhead of the actual processing that is involved.
Absolutely. And there's something really important actually that's just struck me, which is worth pointing out at this time. One of the problems that we've had in the past when building distributed systems is that, for example, imagine that this process purchase order mechanism was provided via a server running on the Microsoft platform. And imagine the client application was running on, I don't know, a device or a non-Windows platform. How would, in the traditional sense in object-oriented systems, how would the client application package up a thing called a purchase order which the server could understand? Yeah? So, because my service exposes this thing called a purchase order, which contains this information, here's what it looks like. Oh, and it contains an array of line items, and here's what they look like, and so on and so on. I have all the information I need at my client application to construct classes so that my developers have a good developer experience, and yet perform all the marshalling necessary to serialize those classes and those objects down to a format on the wire which looks just like the contract defined by this service. So now I have the ability, even if I'm not running on the Microsoft platform, if I'm running on, for example, a third-party vendor's Java platform, for example, to be able to take my service definition and the schema for my data structures that I'm passing back and forth across the wire to generate the client-side code and logic necessary to provide a good developer experience for my developers on my local platform, and still interoperate on the wire very, very cleanly. This is something that's been very, very hard to do in the past, and it's something which this kind of technology can really simplify moving forwards.
And the other thing I just want to comment on is, whenever we start having a discussion about modeling these types and getting it to be more rich, more business descriptive, and to be able to do kind of single-oriented operations, then people start asking about, well, I may be moving a lot more information than I possibly need, and I'm ultimately then going to be parsing that and serializing it into these objects. And with the example that I just showed you, you could potentially run into a problem like that. And one of the things that we give the ability to do, both inside of ASMX and then also in WYSI, is you just deal with information from an XML perspective, right? So I could call this POXML. From a programming model, I'm now dealing with the information in its XML state. So as it's coming across the wire, I'm basically just reading that information inside of the SOAP body it's pushing up, and I can do things like then, using pseudocode here, implement like an XML reader and start parsing through that in a forward-only fashion and looking for the specific information that I need for this service. And
ignoring everything else.
I'm ignoring everything else. I'm not allocating memory to then go ahead and create this complex object model. So even though you're still moving a lot of information, you have the ability to parse through quickly for that specific, more atomic, fine-grained information you're looking for. So,
although of course we'd take care to ensure that the schema that we design for the messages we pass across the wire is as terse as possible and doesn't include too much superfluous information.
Yeah.
But yes, you're absolutely right. We may just need a certain small piece of it. We can just fire hose read through the document until we get the piece that we need and discard everything else. Yeah. Saving considerable amounts of memory and therefore garbage collection, which can impact performance quite significantly.
And I just typed something up on the screen, because you remind me of something.
There you go.
We're talking about schema and the importance of schema, right? To drive this, to drive my my message types. it's just as important if you want to go ahead and reuse that schema to do validation. So this is a great example where I can push a really fat PO with all types of information, and I still want to be assured that the hierarchy and type system is being enforced. So I can employ something like the XML validating reader, which is part of the XML namespace, to go ahead and enforce schema as I'm parsing through this.
Absolutely.
What do you think then are the key areas that people need to focus on in understanding how to take some of the things you've shown them here and put them in practice in their own applications?
Right. So I think, thinking about, at a top level, okay, I need to be using APIs and programming techniques that are going to make me interoperable. So thinking about the specifications that are in the web services stack, thinking about how you go about using the tools. Am I doing this thing, or am I doing this action in a way that's going to make me, interoperable? And then on the compatibility side is then thinking, okay, the decisions that I make, am I going to be able to compatibly interact with the other people that are consuming me? So you asked about, well, maybe there's going to be an IBM WebSphere on the other end. So you need to do that homework to make sure that the person, on the other end right now is going to be doing things in a compatible manner. And then using higher level techniques like policy to enforce that behavior instead of doing it through code.
Absolutely. So my key takeaways and guidance would be to follow the guidance that I've got published on the blog at the moment, which will be in white paper form in the next few weeks. Write ASMX services wherever you can. Use the .NET framework. It's an incredibly rich framework and powerful platform to be able to build distributed systems upon. But then also potentially look more broadly across the Microsoft platform for other technologies and products that can really help accelerate and or simplify your distributed systems, such as, for example, BizTalk, which I know you're a big fan of.
Yeah, and we'll switch over the demo quickly, and then there's some things in BizTalk that basically layers on top of the foundation that we just talked about. So we talked about building, compliant and interoperable ASP.NET web services and things like adding filters and things for extensibility. BizTalk Server then takes that to the next level to allow you to aggregate and control business-oriented process on top of those services that you built.
Okay.
All right. So in this last piece of the discussion, I quickly wanted to do a kind of small demo and walk through some features of BizTalk Server 2004. And these features really correlate back to a lot of the concepts that Richard and I were talking about. BizTalk has a myriad of features for people building service-based applications, both inside of the enterprise and then also externally connecting to partners and other businesses. What I want to drill down onto are really three different concepts. I want to go back and touch on the concept of schema and defining messages. I want to talk about process orchestration. So if I've built a set of services that I need to then aggregate and orchestrate in some type of specific business fashion, how do I do that? So I have those ASMX web services or those WYSI-based services. How do I aggregate them into some type of business process? And more than likely, that business process is going to be pretty complicated. So we talked about these long-running, chunky, oriented services. How do I do that? So looking at the screen here, what you'll see is the schema designer inside of BizTalk Server 2004. The schema designer is an XML schema compliant designer that will both import existing schema that you can edit, or you can, on the fly, looking this in a graphical manner, go ahead and add additional schema information. So adding new element or attribute information, changing namespaces, etc. And what this ultimately does will create an XML schema artifact that is compiled down into a .NET assembly that then is reused throughout a lot of BizTalk interaction. So whenever a message comes into the BizTalk system, into the message box, it will go ahead and apply this schema to do things like validation. We said that could potentially be a very important piece. Is the data that I'm getting the exact data that I expect? Is it safe? Is it parsable? And the schema can then be used as well in the web services that you create. So I can then take and compile this down and reuse this in my ASP.NET web service. So I've defined here, a fairly simple purchase order schema. And the reason why I've done that is that ultimately I have some type of orchestration or business process that I want to model that will make use of the information inside of that schema. Now, what you see here is a simple flow that I've designed using the BizTalk Orchestration Designer. On the left-hand side, I have a receive port, And the port is both an abstract concept and a concrete concept. So abstractly, a port is a place where I receive messages from. Concretely, at runtime, I will bind that to some type of transport. In this case, we were binding it up to a web services-based transport, which is one of the nice features of BizTalk server, is that it can also not only expose orchestration as a web service, it can consume web services. So the investment that we just talked about going down the ASP.NET route flows nicely over into the BizTalk server development experience. So I have a port. That port is then going to initiate this orchestration, and what you'll see here is that it's receiving a message. And the type of message that it is receiving is bound to the schema that I just showed you. So it's expecting to see a message typed against the schema that I showed you in the orchestration designer. Close the properties window here. The next thing I want to do, this is another challenge of building service-based applications, is the type of data that I get may not be the type of data that I need. So I've typed that PO to look like the format that I expect to get from my consumers, but the type of data that I need to interact with underlying systems may be completely different. If I flip over to this window, what I'm showing you here, this is the the BizTalk mapper, which allows you to map one data type model to another data type model. So here I have a schema of my PO that I showed you mapping to another PO that down at the bottom, we've done all types of mental gymnastics to kind of reorder the sequencing of information. And what you see here in the middle, these are called functoids. These are special helper functions that'll do things like string concatenation, database lookup, etc. The nice piece about this is this compiles down to an XSLT file, which then BizTalk employs to do this transformation on the fly. So whenever that message comes in on that given port, a pipeline will run and will execute this transformation. So thinking about this just from a pure ASP.NET Web Services perspective, this is something that you may do through code. You know, we do your own object mapping. Or if you're having to do this a lot, you know, in a very complex environment, you can use a tool like the mapper to compile this down to a reusable XSLT scheme, to a reusable XSLT file. So I've received it, I've mapped it, and inside of this orchestration, I'm calling off into the rules engine, which is something that we're not going to talk about. But again, whenever we're thinking about services, we're usually going to be having to execute some type of business rule, possibly with inside of the service before I execute an underlying business, a business component. So I need some type of flexible way to compile and change those rules on the fly. And then the rest of this schedule is dedicated towards fanning this information back out to a set of services. So that service may be another web service. I may have a service that's fronting a queue. Maybe it's sending it to a database, etc. This really highlights the power of BizTalk being able to talk all different types of dialects. So at a core, we speak XML, but the dialects that we speak on the wire, you know, range from SOAP, EDI, FTP, file, to line of business applications like something complex like an SAP iDocs language. Now I take this orchestration and I compile it down, and I can interact with that orchestration through a number of ways. So I've compiled this down and I've exposed this as a web service. And what you see here is a Microsoft InfoPath client that's going to take some information, complying against that schema that I showed you, and submit it to the web service. That web service will in turn send a message into the BizTalk database, which will execute this schedule. So I'm going to go ahead and run, and we'll see there's Robert Hess's name here, and we'll change this over to my name, and we'll say that I live in Washington, so we'll just keep it like that. So I go ahead and submitted this, and what you see here, this is a view into, this is a SharePoint porter view into a lot of the behavior that is being modeled by the orchestration. So this area in the middle is basically the fan out areas, the destination of that message as it was flowing through. And the highlight of this view here is down at the bottom. This view here is a pivot table service that is bound to some features inside of a BizTalk server called Business Activity Monitoring. And if I hit refresh, if everything is working correctly, you'll now see that a new entry has been added into pivot table services, specifically for that message bound to that purchase order and that orchestration that I just showed you. flowing in real time. So this is an extremely powerful feature for people building service-based applications, is they want to glean real-time meaningful information for that schema-oriented data that's flowing through. So I've intercepted it using business activity monitoring on top of that orchestration. And we'll go ahead and change this again to someone else. We'll say Don Box. Don Box. And since Don makes a lot of money, we'll order 10 sprockets for him. And we'll go ahead and hit refresh. Do it again. And now we see Don show up. And we see all that aggregated information, appearing real time. It's really the power for a service-based developer building a connected system in relationship to BizTalk servers. I have the ability to create schema to drive business process. I have the way to design business process in a very flexible design surface inside of the Visual Studio environment, and I have a way to intercept and then reflect information up to the business analyst that's driven in business terms, which I showed you with business activity monitoring.
Mm-hmm. Mm-hmm. So essentially, we're seeing how BizTalk flows in the same pattern. We talked earlier about web services doing the back-end business logic. BizTalk is now providing the connectivity between the data models and allows you to even see it visually on the screen like this.
Mm-hmm. Exactly. Yeah, and the investment, I think I've probably said it 2 or 3 times, and it's important saying again, the investment that you make in ASP.NET Web Services today and applying the development methodologies that we talked about flows directly over into the BizTalk model.
Okay. Well, thanks. I mean, we're out of time now, but I'd like to get some quick input from you on where you would recommend for resources that the audience might use for understanding more about how to do some programming against connected systems and BizTalks and ASP.NET.
Okay. Do you want to espouse yours, or?
Okay. Well, I kind of mentioned earlier on, we have 3 white papers that we are working on literally right this very minute. We'll have those up on MSDN very soon. I'll publish information on the blog as to when they're available and where to go and get them. But they will be covering our prescriptive guidance around when and where not to use various technologies. ASMX versus enterprise services versus remote and comparative performance comparison, and relative performance comparison, and system.messaging versus MSMQ, COM-based API, relative performance comparison. So hopefully with those 3, you'll have a great deal of information that you can use to go ahead and build services today.
And plus, you've also got a blog that you talked about this.
I've got a blog as well, yeah, unfortunately. It's blogs.msdn.com whack Rich Turner 666. And there's no significance to the 666, I hasten to add. But yeah, if you're interested in this kind of discussion around service orientation, around when and where to use our technologies and how to get to Indigo, it's actually called The Road to Indigo. So okay. Feel free to come over and espouse your opinion to me as well.
Okay, so I'll take a note in the transcript window at the very bottom. I'll take and put links to the white papers when they come out, as well as to your blogs and stuff like that. And Derek, what do you?
So there's basically 3 places. Obviously, the Web Services Developer Center on MSDN, and if if you're looking for guidance around architecture, the protocols, process, and the basics around building web services, that's the place to go. The second place is right now we're hosting a worldwide developer evangelism process. It's called Community Days. It's being hosted in 33 countries worldwide. It's being sponsored in conjunction with DevX. That is a day-and-a-half drill down into building connected systems where we get deeper into ASP.NET, WYSI, BizTalk, etc. So that is something that we're encouraging people to go. Regionally, hopefully there's in one of those 33 cities you have the ability to walk, swim, bike, or ride, however you can get there. And then the last piece is we've just developed a new ISV developer center that has a connected systems focus as well. So if you're an ISV out there looking for guidance, you can go up to the MSDN ISV developer center and get additional information on connected systems.
Okay. Well, thanks. I'll put links to that in the bottom of the transcript as well then.
Well,
thanks for joining us. I appreciate it.
Thanks.
So hopefully that gives you an idea of how some of the programming aspects are of connected systems, how you might be able to use BizTalks, ASP.NET, web services to aid you in developing connected applications. Thanks for joining us.
With me today is Jennifer Ritzinger. She is a group marketing manager in the Platform Evangelism Group. Jennifer, welcome.
Thank you.
So Platform Evangelism Group, that's Robert's group, so you must work with Robert.
I do.
But what do you do specifically in that group?
So my team is kind of the marketing and miscellaneous group. I have several things on my team that we do. So evidence is a big part of what we do. We work with customers to make sure that we're writing up case studies and white papers and doing videos on their projects. We're also working with the analysts to make sure that they have really good customer references that they can talk about. My team also works with the regional directors. The RDs are partners all around the world who help us evangelize. I work with the field, developer evangelists in the field who are working with the community. And then also we have a platform lab, Building 20, that I manage.
So tell me about that lab. I've heard some things about that on campus.
So this is a facility that has customers and partners through, hundreds of them a week, where they come and hear very early from the product group about certain technologies. So it's like we run little SDRs constantly, and they get early inside access. They get to play with the bits. They get to go into their own little office and replicate their environment and play with the bits and have the product group tell them, troubleshoot with them on a certain product. So it really helps them in their adoption choices.
So it's their own little playground.
Yes,
Sounds like that.
exactly,
Sounds fun.
sandbox.
How does one get able to use that? Do they just have to send a request, or they have to be a certain partner?
So it depends on the product group that's sponsoring the lab, and they send out invitations. The best way to get involved is to work with your local Microsoft office and have your developer evangelist nominate you for a lab.
Okay. And so with your job, it sounds like you must travel a lot.
I do.
Do you?
Yeah, all over the world.
Really? What are some cool places you've been to?
I've been to London, I've been to Australia, I've been to New Orleans, all over. It just depends. I go where the customers are.
Right. That's great. So what are some things that you're working on specifically, if you can talk about that?
So right now we're working on WIDBE adoption, Yukon adoption, smart client, connected systems. So we're working with customers and partners, trying to get them ramped up on these products and making sure that when we RTM, when we go to launch, that they're going to stand up there with us, shoulder to shoulder, and talk about what a great product it is, what a great technology it is, and how they've experienced a lot of benefits. And so that's specifically what my team is working on now.
What would you say is the most challenging thing about your job?
There are several. They're all good challenges. One of the hard things is making sure that when we do case studies, for example, with customers, that we're really talking about the tangible benefits, that we're really delving into the project, really talking about, we don't want it to be a big commercial, kind of a rah-rah thing for Microsoft. We really want the customers to talk about the good, the bad, and the ugly, their pain points too, because learnings can come from that. So striking that right balance is something that's an ongoing challenge for us.
Okay. And so when you're not traveling, what are some things you like to do outside of work?
Well, let's see. This summer I did my first mini triathlon. It was a sprint.
Cool.
So I'm not athletic at all, and so that was kind of a big achievement for me. I just wanted to get across the finish line, and I did. And then the rest of the time I'm just sitting on my couch, being a couch potato, watching reality TV all the time. I have 2 replay TVs, so I can't get enough.
Right, so you can get the ones that show at the same time. What are some of your favorite shows?
Oh, well, Real World, Survivor, Fear Factor, Amish in the City, Faking It, you name it.
I have to admit, I've been watching Amish in the City.
Do you like it?
It's really fascinating. It's like a mini documentary.
I know, those city kids are mean.
They are. So besides reality TV, what are some other things? Do you go to movies a lot?
I go to movies, and we've been having a gorgeous summer in Seattle, so trying to get outside as much as possible, swimming, running, whatever I can.
Really active. It's more than I can say for myself. That's good.
Well, that's just like one small part of the year, and then the rest of the time I'm on my butt.
Back in the office. So how long have you been at Microsoft? Where do you see your career going?
So I just had my 7th year anniversary, and I don't see myself going anywhere in terms of leaving the company. Microsoft is it for me. It's just a choice I've made. I just love working here. I always have. And I just hope that I can continue to work with customers. That's just really a passion for me, because they really understand our pain points. They make it real. I don't want to be in the ivory tower all the time, not understanding how customers are using our products and using our technology. So as long as I can keep on the front lines a little bit, that's really important to me.
That's great. Well, Jennifer, thanks for joining me today.
Thanks very much.
Well, that brings us to the end of another episode of the .NET Show.
And stay tuned for our next show on Active Directory Federation Server.
Or ADFS for short. And until then, we'll see you on the web.